Good afternoon, good evening, good morning, good night, I hope not. To all of you, welcome to this ChemDraw Connect with a focus today on natural products. I'm Pierre Morieux. I'm also known as ChemDraw Wizard on the internet. I'm a product marketing manager for drug discovery here at Revity Signals. I am not joined today by Lindsay Rickershauser. Maybe she will join the end of the webinar a bit later. She's the product manager, but she has had she's had something to deal with at home, and she won't be able to join us, at least for the first part of this webinar. So today we are going to go through, I don't know how many of you have seen a ChemDraw Connect before. I don't know how many of you have watched some YouTube tutorials that I have made in the past 10 years. This is about tips and tricks and getting the most out of your current version of ChemDraw with, as we said already, a focus on how to draw and represent natural products. Before anything, Revity Signals, maybe it's a name that you see and hear for the first time. So a little brief overview of what it is. Revity Signals is, we have changed names back in May this year, and we are a software solution provider that empowers chemists and biologists and decision makers to gain critical insights from any type of scientific research data, chemical, biological, anything else, to increase the chances of success of research projects. So Revity Signals. ChemDraw is now Revity Signals. Signals is our platform. Some of you may have heard about Signals Notebook before. So it's our cloud native electronic lab notebook that is natively integrated with ChemDraw. And the entire platform for research is powered by Spotfire, which is one of the market leaders for visual analytics and dashboarding. All of that, to which we have added a layer, obviously, of chemical and biological intelligence for scientific research data analysis. So before we start, I am going to put out one little question. So in the GoToWebinar window, you have a questions pane. I'm going to leave this for maybe 20 to 30 seconds. What would you like, excuse me, what would you like the topic of our next ChemDraw Connect to be about? So today is about natural products, natural product photosynthesis. Next one, I have an idea already, but please type your suggestions into the questions pane. Some examples maybe, and they're just examples just to get your idea started. Fragrance molecules, supramolecular structures, semiconductors, organometallic complexes, inorganic structures, inorganic scaffold, things like zeolites, cucurbiturials, rotaxanes. Did I say zeolite already? So really, in the questions pane, please type in freeform a broad category of molecule that is of interest to you, and maybe we will cover that in our next Connect session. Are we getting some people to participate? Is my next question. No, gonna leave it 15 more seconds. Would be nice to have some suggestions in the questions pane. Just type your suggestions in the questions pane. So we have some people who have supramolecular structures, supramolecular lipids. Okay. Cannabinoids. Good one. Polymeric macromolecular architectures, semiconductors. Very good. Well, leaving this for another 10 seconds, and then we're going to move on. But thank you for Thank you for submitting a few examples. Inorganic metallics, biologicals, and peptides. Wonderful. Thank you, everyone. We're done. No, I'm joking. It's a terrible joke. What we're going to see today, one example is how to make, for example, a slide like this. Maybe I have another molecule that we're going to use as an example, but in a nutshell, oh, I didn't change the animation. I made it flip. So this is the a natural product, and I'm sorry, I'm blanking out on the name. This is by Professor Maimon's group. I mean, this specific synthesis when I made it, so I apologize for not remembering the name. This is the 2D classical version drawn in ChemDraw with the color with the coloring options. This is the 3D that's been generated within ChemDraw, and with certain levels of ChemDraw, you now have a possibility to take that and then paste this 3D molecule as a native 3D object in PowerPoint, which can then be animated, and we'll see a little bit about that. Right. So in essence, you can have 2D in ChemDraw, that obviously you know. 2D flat representation with wedges and hashed wedges, that can turn into 3D in ChemDraw, and then this 3D in ChemDraw can then be transferred as a native 3D object, to be more precise, a 3D printable object whose format is natively supported by Microsoft in PowerPoint. So also, obviously, you have a transfer of color highlights, which is very convenient for communicating accurately, communicating chemistry accurately. Another example, this is something that you are now able to do. So I'm not going to go through more examples of those. We will have a look at maybe some more slides and maybe some more techniques dedicated to using ChemDraw, and also I will have a few tips and tricks on how to use PowerPoint in conjunction with. Excuse me, I am a little bit sick, so my throat is really hurting. We have a small outbreak here in France, where I'm based. So talking a lot actually hurts my throat a little bit, but it's okay. We'll manage. I apologize if I just cough all the time. This is one of things that we're going to go through, tips and tricks to quickly and efficiently represent, to do multi-step synthesis essentially, and draw intermediates and draw the various intermediates very quickly. And I'll show you some tips and tricks on that. And we will see also tips and tricks on how to animate things in PowerPoint and work with slides in PowerPoint and work with structures in PowerPoint as well. So what is this structure? For this structure, I have picked one of the many syntheses that are available in this wonderful website, which is Chemistry by Design, which is created and maintained by Professor John Njardarson and his team at the University of Arizona. I apologize if I mispronounce his name. I know he's Icelandic origin, so I don't know if it's John or if it's Jan. I've heard Jan before. So Professor Njardarson. If you don't know Chemistry by Design, it's a great website. You also have apps, and it runs pretty well on your smartphone, actually. Chemistry by Design is just a compendium of all, not all, but many total synthesis with the schemes, with the author, and you can search by name of the product, natural product. You can search by name of the author, and you see how many total synthesis they have on this website of this author, the year in which the natural product was synthesized. So you see, for example, 2022 was a very prolific year for total synthesis of natural products. If you are into drugs, the actual marketed drugs, along with who made it, which company made it. And every time that you select one molecule, you will see on the right-hand side, for example, the structure of the drug, and you will have the synthetic sequence here of how the drug was made. And the last one, the last slide will usually include the reference. So take, for example, I'm going to take, for example, here for today, Chatansin by Maimon in 2015. Why? Because it's polycyclic, it's bridge cyclic, so the 3D is going to work well on that. Also, I didn't want to take a 31-step total synthesis because that may be a little too long. Not that we couldn't do it in 1 hour, but this one is 9 steps. It's enough to show you how to draw simple and less simple molecules with hotkeys, and then how to use the reaction shortcut to just quickly go through a succession of steps. So I did try to figure out the best way to do this, because I can't do it by head, by memory. Also, it's also for you to see what I'm actually doing. So we're going to split the screen in two like that. I think I just need to zoom out a little bit for some of the intermediates so that it's seen. Okay, and then you should be able to see things. I'm going to do Control A and delete. Also, excuse me, what you will see on this part of the screen is a little widget that shows you what I am typing on my keyboard. So letters, numbers, arrows is very important. And then, shift arrow down, shift up. This way you can follow what I am doing. So let's start with a couple of things. We start with this starting material, and Microsoft Search, no thank you. Obviously, some of you know, they know me, but maybe they don't. I don't draw molecules with the tools within ChemDraw, okay? So what we're going to see is how to represent and draw those molecules, and then draw those steps using mostly the keyboard. But obviously for some of the steps we will need the mouse. So the basic principle is you insert a bond, and then you take a selection tool, like the rectangle tool / the marquee tool. Then you insert a bond. Once you have inserted a bond and you have a selection tool, you can, for example, touch a molecule by just touching a molecule, not clicking on it, but just touching on the molecule. You're going to activate the hotspot on that molecule. So that's just a CC bond. And then the hotspot, it can then be moved with the arrows on your keyboard. And then start simple. You can make one, you can press 1. 1 is going to add a CC bond towards the green dot. That's what the green dot is for. 0 is going to go away from the green dot. In other words, 1 extends as a chain, and 0 cyclizes. This is another way to look at it. Once you have drawn a molecule like this, you can press space. Space is the hotkey to select the rectangle tool, the marquee tool, which in turn selects the last object you interacted with. Another hotkey that you have is, if you are not mousing over anything on the canvas, you see solid bond X, or 1 or 0 on an atom. This is what we just saw. If you are not mousing over any molecule on the canvas and you press X, then you switch to the single bond tool. Okay. I am not going to give you a full overview of all hotkeys. If you are on version, so the current one is 22 or 21 or 20, you will start ChemDraw for the first time with this cheat sheet. This cheat sheet will tell you if you are on primary carbon and you press 0, 1, 2, 3, 4, 5, 6, 7, 8, etc., you're going to get this. If you are on the primary carbon and then you press those, you're going to get those atom labels. If you are on a secondary carbon, some keys will do something different, and so on and so forth. And then the same goes for the bonds, right? So we are here, and we're going to start. So I touch this molecule. Well, I touch this CC bond, and then, for example, I press 6 over a carbon atom. It's going to add a cyclohexyl. Then I press O over the atom. I add an oxygen. I move down. I press 2. 2 is going to add a ketone on a secondary carbon, but 2 over a bond will make it a double, right? So it's always context sensitive. Atom or bond matter very much. If you are over a bond, you press 2, you press 1, you press 2, you press 3, you press 1, you press 2, you press 3. It's going to toggle between the various things. Then you press O, then you go over here, and then the gem dimethyl is 9. If you press 9 over primary carbon, it adds a dimethyl. If you are over secondary, it's going to add a gem dimethyl. Then you press space, and the reaction shortcut that we want is Control arrow. Control arrow right is going to clone whatever you have selected. Can be one molecule, can be multiple molecules, can be an entire reaction scheme, can be a picture, one of the image templates, and it's going to clone it on the other side of an arrow, which is in the direction of your keyboard arrow. So if I'm here and I do Control arrow right and down and left, then it's going to add. It's going to clone my selection on the other side of an arrow. This is the reaction shortcut. So I'm just doing Control Z here. And once you have, so this is only since version 20, so you should check your version, which also makes me think. I've scattered mine sometimes. If you Google ChemDraw ChemOffice subscription gallery, you will get to this webpage where you can look for if your institution has a site-wide license for ChemDraw. So this is Aalto University in Finland. It's alphabetical order. So you can find things here. And remember that if your university or your institution has a subscription for that, you are entitled to get and to use the latest version of ChemDraw. So always bear that in mind, that you always have access. If your university has a license, subscription license for ChemDraw, you always have access to the right to use the latest version of ChemDraw. Okay, so since version 20, if I remember correctly, if you have a molecule selected and you press Enter, you alternate between selection of the molecule and the hotspot, right? So take this, for example. We have to make this intermediate. So I just move around with the arrow on the molecule, nothing more, nothing less. Then I press 2, and then I press 1, then I press 2, then I press 1, and then I press Enter. Enter over an atom label is going to start the text tool. Tom's TS. Okay. Then, then what do we have? Click next. Click next. We have this and Control arrow right, and Shift arrow right is going to move by 10 pixels. It's an old shortcut before version 20, I believe. Before that used to be Alt and arrows to move by a large amount, so 10 pixels. And now it is more Shift with the arrows. So then we have this intermediate here. I'm going to start here and 0, 1, 0. 8 is for double bond. 9 is dimethyl, as we have seen. Shift and arrow is going to make the hotspot jump from longer distances and then go over non-connected parts of the molecule. So I press 8 and press 0 to go away from green dot. Press 1, sorry, press 0, 1, I press 4. 4 is going to add a wedge bond plus a methyl. And that, and then press CHO, enter, and then CHO. So we have that. And BF3, how to do the proper dot for BF3 iterate. You go to edit, character map, and then, so on PC is Alt 0256. Okay, type that. I press escape to escape the text tool. I press space to select, and then Control F. Control F is formula, so it's going to turn the 3 and the 2 into indices. Okay. Now we have that. What can we do? Double clicking on a molecule is going to select the molecule, and I hold Control. I'm going to click and drag that here. Okay. What can I do from there? I can delete that and do this. Now, what can I do here? There is a menu in the object toolbar. Sorry, there's an item in the view menu, a show object toolbar. And since version 20 or 21, I actually don't remember now, we've added an icon for the joining function. So the joining function is you select 2 atoms, right? Like this, or you select 1 atom, you hold Shift, and you select another atom, and then you hit Control J or join, right? And that's going to join the 2 molecules together. An alternative, Control Z. The alternative could be, of course, that you do this. It's not very elegant, but that works. Or you take this and you position them in such a way that the carbon are closely, very, very closely overlapping, so much overlapping that you get an error. And then you select both indiscriminately, and within those molecules, you do, with those molecules selected, you hit Control J. And what, so that's a little trick. When you have large molecules, when you have large molecules, or sorry, multiple molecules, where you have very, very, very closely overlapping carbons, select all that. Control J is going to join together by pair all the carbon atoms that are very closely overlapping, which is what I just did here. So I have that, and then I press Enter to go back from selection into hotspot. And what we have here, this is O, so I go here, I press 2, it's going to make a double bond. I press 1, I go here, I press 2, I go here, I press 1. I go here, I press 1, and I press O. So it's not exactly how it's represented. So I'm going to press space to select, hold Alt, and Alt arrow down, down. Alt and arrow up or down is rotation by 15 degrees increments by either counterclockwise or counterclockwise, and then Alt arrow left or right is a 1 degree rotation increment. Which, by the way, in PowerPoint you get Alt and arrows as well for rotation. Okay. Need to speed up a little bit because this is only step 3 also, but it's a short synthesis. So we are here. Going to continue going in this direction. And again, select, Control, arrow right, press Enter, and this is oxidation reaction. So we press 2 over the bond. Also, we take that, just because I want to represent it exactly as it's depicted on Chemistry by Design. I'm going to do that. Then, next step. Heat in toluene, sorry. to get back into ChemDraw before pressing that. Okay. So here, one thing that you could do potentially is if you understand what's going on here, this is the key tile is gonna jump, and then there's going to be a bond between that oxygen and then that carbonyl. So what you could do is, for example, very awkwardly do this, and there's that, and then that water is going away. You do that, and then Control-Shift-K. Control-Shift-K is your classical 2D cleanup, and I forgot a little double bond here, right? So we have this, which is a quick way to get to that. And then we are going to have put the triflate on. So Control arrow, enter, and go here, and then OTF. Okay, now the next step. The next step is the interesting one. It's a DL solder. And the DL solder, do I have the paper still on? Yes, I still have the paper on. So this is the actual paper, and this is the proposed intermediate for. So it's actually intermediate 12 that is happening. So we're going to use the 3D cleanup to represent an intermediate like this one. How does that work? We're going to take this and give us a little bit more space. Actually, let's go in the other direction. Going to take this and then Control arrow down. Right? So we're going to continue on that side. Maybe we're going to go towards the left then. Control, click and drag. I'm going to make a copy. And let's start there. What I like to do is put some colors because that's going to help a lot in, of course, my coloring bar appears on my other screen. In colors, highlight colors. So color highlights is since version 20, and ring fill colors is since version 19, but you need ChemDraw Professional at least to get those capabilities. We're going to go with the highlights simply just to make it easier to follow. And let's say it's this bond, and this bond is involved in the Diels-Alder reaction. So how would you go about drawing nicely the intermediate? First of all, just take this. I'm going to make a copy again. Control-Shift-D, or this icon in the structure toolbar. So structure toolbar again is View menu, Show structure toolbar, and the icon on the right is the 3D cleanup. Or you need ChemDraw Professional for that. Or Control-Shift-D, D like 3D. Control-Shift-K is the 2D cleanup. Now that I call it 3D cleanup. Control-Shift-D or Command-Shift-D on a Mac is going to, you have to press it multiple times. So you don't see it, but I'm pressing multiple times Control-Shift-D, and it's going to give me something like that. Right? So it's going to give me a possible confirmation of the molecule in 3D. Mind you, this is not what we want. This is not what the intermediate step should look like. So what do we do? Well, we're going to cheat a little bit. So we're going to make the final. We're going to make the final compound first. So I'm here. I press 1. I press 2. I press 1, and then this one's going to go off. And then I am just going to cheat and do this, right? I'm going to do that and that because that's what happens when you do a Diels-Alder reaction. So like that, Control-Shift-D. Okay, so what can happen here is a couple of things that can happen. in the paper, we're trying to achieve a chair, a 6-membered ring here. And the 3D cleanup is not necessarily going to give you the chair confirmation that you want from the get-go. There's a little bit of nudging that you will need to do to get to a chair confirmation. So it may involve rearranging things manually. Okay. So we're moving things a little bit here. I think I'm getting this wrong. Maybe this is not the right. And I'm getting this wrong, I think. I had it this morning, but I'm getting it wrong because I'm doing it live. So the bottom line is the following, is that you are going to generate the actual product and do the 3D cleanup. And then it's cheating, but you're going to remove the link, the linkage. And then, for example, you may say, going to put back a double bond here, put back a double bond here, put back one, put back a double bond here. And there you go. You say you have your intermediate, right? So the intermediate that is properly positioned for the DLZelder, you can have that here. Doesn't look too happy. I think I got the wrong one, but that would also indicate that it's not going to work. So then you have this, and what you could do, from here is copy as 3MF. So what is copy as 3MF? It's a function that you have in if you have ChemOffice, and it's going to copy this as a 3MF object. 3MF is a 3D printable format natively supported by Microsoft PowerPoint. And if you do Control Shift Enter in PowerPoint, it inserts a new slide. In my clipboard, I have a 3D printable object that I'm going to do Control V. But this is our guy. And Shift Up or Shift Right in PowerPoint is make things bigger. You have the handle, and this is your DLZelder pre-DLZelder reaction, and you can have that. The nice thing about those 3D objects is that you can natively animate them. So this is the turntable. You make it turn like this. You make it turn from the top down, and then you can accelerate. You make it rotate faster. You make it swing if you want. This is much easier to animate and then to communicate. Okay, so we're going to go back to our molecule here, and I'm also realizing that I forgot the triflate. So let's start from there, and let's do. So we're going to do that, and going to do 1, 1, and this is 2, and we're going to see. I believe this is this, and like this, and I'm going to do Control Shift D. I'm just verifying that this is good. And sorry, triflate actually becomes so we have this. I think I'm getting things wrong. Yes, I'm getting things wrong. I am sorry. I'm going to try to make it better, make it quicker. I thought I had this all nicely set up this morning. Maybe it's okay, and let's do that. And yeah, I think that looks better. Looks better. So it's this one. There you go. We're getting there. And this is CO2. Okay, so we have that, and you can see that this is effectively what we have here. I'm going to press 1 and then H, and so we have the bridging ester on top going up, and then we have this here and this here, and this H over a bond is going to give you a hashed wedged. Sorry, that was a little bit more complicated than I anticipated. Control Shift K, and then if we want to have the equivalent, so Control click and drag, and Control Shift D, Control Shift D a couple of times, is going to give us that. So you see in that case, actually it looks a little bit nicer. So you can see the 6-membered ring is an actual chair. As I said, if you have a 6-membered ring, it won't always get it nicely in the chair conformation. You'll need to do some nudging yourself and then do the 3D cleanup again. But then you will be able to get to something like that, right? So this, in proper, it's not very nice, but I know this is equivalent to, and this is where you would put, this is where you would put things nicely in a, like this in your publication. Maybe this drawn a little bit better than to match a little bit more this style, but that would be your thing to do. And then let's continue, right? So imagine you are here, and then I do realize I am not entering the proper conditions each time, but there isn't at the moment a nice trick that I can show you. So just a couple of things here. Did I get that wrong? No, I didn't get that. Like this. And so we have that, and then we have that. So I'm here, I press L over the atom. Pressing L over the atom is going to give me a chlorine. And then next step of the reaction, we're going to go down. Next step. So we go back here, here, here. I don't really have a proper trick if that is, pressing 0 here to close the ring, and pressing that, pressing O, pressing H, and here that would say manually change things. Okay. So we have that, and then we have that. And then here, W over a bond is going to give you something like that. So here I could just take it and then nudge it a little bit. And again, I could take this and do Control-Shift-D to have a nice representation. So example again, this is not share. The cyclohexane does not share. So I'm going to do this, nudge it manually. Control-Shift-D. There you go. So now it's more the chair cyclohexane. And that is more in line with what we have. This is the actual cyclic structure of the actual 3D structure of the natural product. And then the last step is simply hydrogenation. So I'm going to take this and then this, Control R right, and then have something like this. Once you have something like this, so this is our natural product. Just for the sake of presentation, if you want to, when it's represented like this, and you want to highlight a specific ring, what you can do is circle one of the rings, and in its entirety, that is ring fill, and then let's do green, right? So you can see better. Let's do this one in green, and perhaps I think having this one in green should be sufficient. So you can take that and go to your PowerPoint slide. You have your ChemDraw drawing here. Shift up multiple times to make it bigger. And then you can take this, Control-Shift-D, multiple times. So again, just tweaking so that it's in chair, Control-Shift-D, there you go. You can take that and paste it in PowerPoint, Shift up to make it bigger. And then the final thing would be you can do copy as 3MF, so you need ChemOffice for that. Go into PowerPoint, paste. And this way you will see here. So the ring fill color translates into sort of a plastic wrap around circle. So if you have a flat benzene ring, it looks nice, but it will look a bit with extra volume if you fill in a ring that is not flat, as it is the case here. But it helps you visualize that what is green is actually a six-membered ring in this molecule. All right, so I took a little bit longer than anticipated, a little hiccup, but I wanted to really show you step by step how you can do, obviously you can do it faster once you get a hang of it, how to easily represent a multi-step total synthesis with mostly the keyboard on your computer. The one thing that didn't show was really how to insert all the reaction conditions every time. So for this, the only trick that I would have would be to use the text tool. So the text tool, you see if you mouse over the text tool, it says T or press enter on atom. This is one that we have seen already. You mouse over an atom. With the hotspot on an atom, you press enter, and it starts the text tool, right? But you can also press T. So if you press T while you're not mousing over anything, you press T, it starts the text tool, and then you can have reactants, and then you can have conditions, for example, okay? And then double clicking on an arrow is going to select the reaction arrow, and then you can always clean up the reaction, or Control-Shift-X, Command-Shift-X on on Mac to clean things up nicely. Okay. Given that we have 15 minutes left, I am going to stop now. I'm going to thank you for your attention, and then I hope this has been helpful to you. So really, for natural products, the ability to easily generate, well, with colors, a 3D confirmation of a molecule, along with 3D 3D models that rotate natively in PowerPoint. And yeah, that's what I wanted to share with you for this ChemDraw Connect on natural products. Now, if you have questions, I hope you have been putting some questions in here. Happy to start answering them. Right? That I am going to back to this. And yes, so in the questions pane, feel free to ask any question that you may have. Right now, I only have the suggestions, but please submit any question you have right now on. So there's one, for example, that is the document settings that I'm using, which is a very good point. I could have started with that. The document settings that I am using, I may do another Connect just on that. You go to document settings, and in the drawing, so it's in points here. Normally it's in inches. There you go. So if you want my setting, I mean, screenshot this is really the proper way to do this. This is the line width. So the line width is you get thicker bonds. The bold width is how thick the bold bonds are going to be. So how wide the wedges are going to be, how the bold thickness is going to be impacted. The margin width is how close the atom is relative to the bond. So it's essentially the white space between the atom label and the bond. And then the hash spacing is when you have hashes, so just the regular hashes or the hashed wedge, how spaced those are on the drawing, right? So just to show you one little thing, if you take this is a wedge, right? So you control this at the document settings or at the object settings. So if I take this molecule and, for example, go to object settings, and why is it in points? Bold, I'm going to make this 5. So the wedge is going to become much wider, right? If I change this to a hash wedge, so I press H, you see the hash wedge is also like this. And then if I select this and I go to structure, object and object settings, and then I change the hash spacing. So if I reduce it to 0.02 inches, I'm going to get more hashes. And if I go to object settings and I go to, it's actually a little too many, to 4, then I'm going to get less hashes. So this is how that works. A couple more questions. Thank you for the note. I hope I can get better soon as well. Thank you, Robert. This technology available in ChemDraw version 12? Absolutely not. This is version 22. I do want to point out, and thank you for making me think of this. Version 12 has been out of service for more than 10 years, right? So it's absolutely unsupported on recent version. So actually, pretty much, apart from the toolbars, from the tools, sorry, just from the basic tools, nothing that I have shown today would be available in ChemDraw version 12. Don't want to stay too much longer on version 12. It's like you staying on Windows 95. That's what I would say. Can you please explain once again how to convert 3D structure from ChemDraw into PowerPoint? So for this, the prerequisites are really that you need to be on ChemOffice. ChemOffice is the highest level of ChemDraw, and only ChemOffice has, excuse me, has the 3D to 3MF object. But once you do, you take a molecule in ChemDraw, so you make a 3D conformer out of it, Control-Shift-D, like this, for example. Right, so I mean, this is not the best example for 3D. It's a bit flat and boring, but okay, let's run with it. And then this is the main. At the top, you have the main toolbar. The main toolbar is, you can view show main toolbar. It's where you have file, open, save, copy, paste, zoom, and at the end of it you have copy as 3MF. Copy as 3MF, which is available here in edit, copy as 3MF ball and stick. So the icon that you have here is copy as ball and stick, but you can also have copy as just the stick if you have a busy large molecule, right? So you do that. And the other prerequisite that maybe, I'm sorry if I didn't make it that clearer, is that you need Office 365, because only in Office 365 do you get a very simple way to look at it is you go to insert and take a slide, you insert, and then you should have 3D models, right? 3D models, inserting a 3D model is only available if you are on Office 365. I think the student version of Microsoft Office is not gonna work. Once you do, Control-Shift-Enter, new slide. So you have a 3MF in your clipboard, right? I was here, I selected the molecule, I said copy as 3MF stick. So I have a 3MF object in my clipboard, and I do Control-V simply. And that gives me the stick version, not the ball and stick, just the stick version of the molecule here. And if you don't like the double bonds, how they are together, there's nothing I can do about that because it's supposed to be a 3D printable object, so the double bonds need to be close to one another. I mean, close to the other, to the single bond. Okay, do you usually use cleanup reaction to align the whole synthetic route? If I do this, it's not going to look pretty. We have improvements to make to, I would also like that you select everything and you do Control-Shift-X, and then you get the nicely cleaned up multi-step synthesis that keeps the arrows. Right now, it's not going to do that. Right now, it's going to convert it into just one line. So right now, what I would do would be maybe double click on the arrows, which selects the individual reaction components, and then Control-Shift-X that, right? Bearing in mind that it's not going to work on vertical or actually going to the left, but that's an improvement we will make in the future. Also, there is nothing written above and below the arrow, which is why the arrow just shrinks. But if you have, like here, something drawn or something written above or below, the arrow will adjust to that. So to clean this up, I would do a succession of those steps, and then potentially, depending on the scaffold that you are working with, you go to View, Object Toolbar, and maybe align the bottom edges or align the top and bottom centers, right? That really depends on the scaffold that you are working on. to make things look nicely on a reaction basis. Okay. Just as a reminder, because it was asked, yes, this recording will be made available. I don't think I said anything too stupid during this webinar, so I think we're going to be able to upload it right away onto our social media channels. And yes, so you will get a recording to that. You will get a little summary of what we discussed today. And with that, I think given that there are no more questions, we're going to try to actually end on time, right on time. I want to thank all of you for joining us today for this ChemDraw Connect, and I hope you will join the following ones. We're planning to really do a regular cadence with ChemDraw Connects every 2 months. So I do hope to see you again next year for another topic that will be inspired by what you have submitted in the questions at the beginning of this session. With that, I wish you a good rest of your day or rest of your night, depending on when you are, and thank you very much for your attention. You take care.